Complex numbers, part 3. How do you perform operations with complex numbers? Well, first of all, the imaginary unit I is equal to the square root of -1. Then, if you square both sides, then I squared is equal to -1. So, a complex number can be written with a real component A and an imaginary component BI. If A is 0, then BI is a pure imaginary number. An example of a complex number is like 2 plus 3i, where 2 is the real part and 3i is the imaginary part. A complex conjugate is any time you have A, the real parts of the two numbers are the same, but then the imaginary parts are opposites. So if you multiply a complex number by its complex conjugate, you would get A times A, which is A squared, A times negative BI, which would be negative ABI, BI times A, which would be positive A times BI, and BI times negative BI, which would be negative B squared, I squared. Let's look at simplifying this. When you add these, it becomes 0. We learned from the last slide that I squared is -1. So negative B squared times -1. And we have A squared. Negative B squared times -1 would be positive B squared. So we have A squared plus B squared. Let's look at this with numbers. Multiply each by its complex conjugate. So if the real part's 3 and the imaginary part is I, the complex conjugate would be 3 minus I. The real part's the same, the imaginary part is the opposite. Let's multiply. 3 times 3 is 9. 3 times negative I is equal to negative 3I. I times 3 is positive 3I. And I times negative I is minus I squared. These add to be 0. I squared is -1. So we have 9 minus -1, which is 9 plus 1, which is 10. Try another one. I'm going to multiply 5 minus 4i by its complex conjugate. The complex conjugate would be 5 plus 4i. 5 times 5 is 25. 5 times 4i is 20i. Negative 4i times 5 is negative 20i. And negative 4i times 4i is minus 4 squared, 16, and I squared. Those are 0. Negative 16 times -1 and 25. So we have 25 plus 16, which is 41. Let's write a shortcut. This can be your shortcut, A plus B squared. Let's see if that works on this one. A is 3. A squared would be 3 squared. B is 1. A squared plus B squared would be 3 squared plus 1 squared, which is what we got. Let's try it on the next one. A is 5. B is -4. And so we get 25 plus 16, which is 41. So if you can remember the shortcut, A squared plus B squared, then you don't need to FOIL or make the box. Multiplying the complex conjugate is important when learning how to divide complex numbers, because in order to write the quotient in standard form, remember standard form is just A plus BI, you are going to multiply the numerator and the denominator by the complex conjugate of the denominator. So we'll start with the denominator. The complex conjugate of the denominator would be 4 plus 2i. Whatever I do to the bottom, I have to do to the top. Remembering from the last slide, in order to multiply the complex conjugates, you can just do A squared plus B squared. 4 squared plus 2 squared. On the top, though, there's no shortcut. 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. Let's simplify the bottom. 4 squared is 16, 2 squared is 4, and we get 20. 8, and then we're going to combine our imaginary parts by adding 4i plus 12i to get 16i. And then remember, I squared is -1. And so now we can combine 8 and -6 to get how about just 2 plus 16i over 20. To write it in standard form, it's going to be 2 over 20 plus 16i over 20, 1/10 plus 4/5 I. Try the next one.